Good day. Today we're going to look at normal calculations. Now in the previous lesson, we talked about the normal CDF function, that being the normal dist in Desmos, and that is the area of the curve between two bounds. But we can use inverse norm function to find the number line value when the area under the curve to the left of that value is known. This is the new part of what we're doing today. Now, this example 1 and you try, both of these you should be able to do already. I'm going to show you the you try and let you try example number 1. For this one, it says sketch the bell curve. There's my normal distribution curve. 3.57 is the mean it gives me. Label the relevant lower bound and upper bound. So we're going to do the standard deviation of 0.32. Subtracting go to the left. 3.25. 2.93. 2.61. I'm going to be adding to go to the right. So 3.89. 4.21. And 4.53. I want what am I wanting to find? The GPA that is less than 3.15. 3.15 is right through here. And I want anything to the left. I'm going to use Desmos to do this. Normal distance, my mean value, 3.57, comma, standard deviation, 0.32. Now I want anything to the left of 3.15. So negative infinity to 3.15. I get 0.095. So 9.5%. That is everything to the left through here. Alright, moving on to the next one. Example number 2. Now here's where we're going to get into some new stuff. Graduating seniors at a certain high school with GPAs in the top 20% are eligible for a special college scholarship. Grade point averages for seniors at that high school are normally distributed with a mean of 2.35. Let me go ahead and graph this down. And a standard deviation of 0.15. What is the minimum grade point average that a senior at a school must have in order to qualify for the scholarship? This says the top 20% are eligible for a scholarship. So somewhere to the right, as our mean is going to be 50%, somewhere to the right of this, I'm going to say about here, is going to give me a top 20% in this scholarship. Now, I don't know what this number is, and I'm going to need to find it. In order to find this number, I need anything on the left side of this line. That is how the inverse norm function works. So I'm going to take my 100% minus my 20%. So the amount on the left side of this is going to be 80%. Alright, from here, I can find the area under that curve to get my GPA. So, my question mark to solve for it. I need to find inverse CDF and Desmos of my normal distribution, capital N, and my area left of this curve. Well, what do we need to find? First, the normal distribution. Normal distance. Normal distance in Desmos of my mean, 2.35, and my standard deviation, 0.15. I need to have A as the area on the left. This is my 80%. As a decimal, this is 0.8. So now I can type this into Desmos from here. Normal distance. I'm going to change it to my 2.35 with a standard deviation of 0.15. I need that to be the N value of my inverse CDF. So I'm going to type in inverse CDF around this. INV, ERSE, CDF, parentheses. Now I'm going to type in that percentage on the left as 0.8. And I get let's round 2.48. So my question mark is equal to 2.48. Approximately 2.48. Well, what does this mean? This means the senior, in order to get the scholarship, the senior needs a GPA of at least, so it could be higher, but at least a 2.48. That is what our information tells us here. Now I want you to try this. So pause the video and try example number 3. Now I'll show you the solutions for this lesson. That is all that I have for you today. Have a great rest of your day.